enough. Hey guys, we are back with a whole new episode where we're going to be talking about carbonated beverages and why sparkling water tastes nothing like pop, and why we shouldn't open them right before we go live.
Yeah, it's everywhere on me. And it's still
Now,
fizzing.
and we actually have a much better broadcast for you. We have something that Ryan is begging us to teach him, which is crossover basics.
Yes, please. I need to learn a few things.
We're going to settle it tonight.
I said,
Yeah.
no, seriously, I'm excited because I think each one of us is going to have something really important to say about crossover basics. And so we're going to be talking today, we're going to be talking about resistors, capacitors, inductors, what's their function within the crossover network, why do you need them, and we'll probably even crossover into the orders of crossovers, first, second, third order, fourth order, 96 decibels per octave. Why do you want them? Why don't you want them? What are the advantages and disadvantages of those? And probably talk some filters as well. Now, having said that, if you have a question about crossover basics, throw them in the comment section. If we have time, we will absolutely answer it. And for those that have to get your question answered, make sure to just throw us a super chat. We do look at those, and we will obviously respond to those. Super chats always get response.
Yep. Before we talk crossovers, do we want to kind of mention what software we use to design our crossovers? We want to save that for later.
Sure.
I think it may be all the same for each of us.
Yeah. I'll go first if you don't mind.
Sure.
Because I actually had paid software a while ago to do my crossover design. I had the SoundEasy suite, and I don't use it anymore. But even when I did have it, I didn't use it. I used the free stuff. I previously used Jeff Bagby's passive crossover designer. It's an Excel spreadsheet. And after that, I was using Bill Waslow's XSim.
Mm-hmm.
And I just found them better than the paid stuff. Like the free crossover designers out there. I haven't used Vituits. I'm sure somebody will bring that up. They're just very good. So I would say if you're going to design crossovers in software, don't pay for crossover design software.
Which I will say this as well. I same exact journey. Well, except for SoundEasy. The rest of it the same. Jeff Bagby's PCD, and then which is passive crossover design. It worked in Microsoft Word, I think it was, or maybe it was Excel. One or the other. It was Excel, but it doesn't work anymore in like the newer versions of Excel. So that's gone by the wayside, as far as I know. If someone knows some other way where they can still get it working, so be. I know Jeff Bagby was trying to get it working again. Just I don't think it was ever able to. And then we moved on. Then I moved on to XSim, which is what I still use as well. I do not use VituxCAD either, but yeah. Yes, Rip Jeff. He's awesome. And it says, A-Dub says, I'm currently listening to his Testarossas. Those sound awesome.
Speaking of Jeff, I saw a video the other day where, if I'm not mistaken, he was introducing someone. It may have been Bill, who is responsible for XSim, and he mentioned that it actually was born from his passive crossover design software. So there's kind of
really?
Yeah, unless I'm mistaken on that. I don't think I am, but yeah, it was actually it worked its way up to become XSim. So it's kind of the foundation.
What else Bill Walslow is?
OmniMic.
OmniMic, that's right.
Well, as well as we're going to be talking about these tonight, both FRD and ZMA files came from him as well. And that's how we kind of simulate these things, which we can get into in a little bit.
Well, so let's start talking about...
Hold on. Before we move away from software, never ever use those online crossover calculators where you type in the frequency and the impedance of the driver and it spits out some crossover parts. Never use those. They are, other than like a theoretical exercise, they're pointless.
That's a really good point.
And there's a lot of reasons for that. Why don't we spend a little bit of time before we go into the crossover components, why that is? Because some of that, for example, has to do with impedance. They tell you to put what impedance is there, right?
Yeah.
Yep.
Yeah. Those designers actually treat the impedance like it's a standard value when that's the issue. Impedance changes. That's what impedance is a changing value with frequency. So
yeah. And so your impedance might be 16 ohms on a 4 ohm driver at your crossover point. I mean, it's impossible to
Exactly.
say what it is or what it is. And that's going to be part of the issue. And not to mention, it doesn't take into account things that, we don't want to get too far down the rabbit hole for people that are still learning, but it doesn't take into things account like the offset of the drivers, which is another big issue. So, your phasing, all those issues, it's going to, you need to take those all into account to make a good crossover point. But you're absolutely right. I still think we should do a build off with a pre-designed crossover board.
I'd love to. I like the idea so much. I will say, Ryan, I love your point. If you are already using simulator software and you're curious about, you want a starting point, maybe that's an okay use case to punch in some numbers there just to give you an idea of where to begin with your component values. If you have no idea, if you're like, does this tweeter need a 50 UF cap or a 6? And you don't know the difference between those, maybe it could help you there, kind of get a starting point. But yeah, again, stay
Sure.
away from those if you're trying to use them outright.
or a protection cap circuit.
Sure.
Joe, I would just say to your comment, you're right. There are some drivers with constant impedance or close, and you can even do things electrically to flatten impedance, but you still have the problem of the frequency response and the phase interaction between the drivers that can't be accounted for. So it's the easiest to explain is to say impedance isn't constant, but frequency response and phase are also wildly changing all the time.
But this would be a good spot to mention. And we're going to talk about capacitors in a little bit later, but a capacitor on a magnetic planar is very important for protection, even if you're doing DSP or taking measurements for that matter. So that's where I would maybe use an online calculator to figure out what size capacitor I might want to put on there for protection while taking measurements.
That's a good point because you're going to want to size that thing to be well within the stop band, so you're not messing with your band pass.
Yep. They also can't account for attenuation, and you need measurements to see where your driver levels are at. So that's another thing. They're going to leave out your LPAD or any type of tweeter attenuation. So you'll be left to do that by ear.
Great comment, Joe. Appreciate that. All right, so let's talk about these. I actually have some right here, and this is not even planned. Actually, I don't know why they're all in pieces, but here's a capacitor, and here is an inductor, and here is another inductor. So got a couple inductors, capacitors, and they're soldered together.
Let's see that solder work. Hold that up again.
Well, you know what? This is very weakly soldered. So
I'm joking.
This was an obvious test circuit for something a long time ago. They never desoldered.
Yeah, like my work.
Well, they're barely soldered, just very touched. Yeah, just whatever. But
top tip: if you're going to prototype, just solder your ends together. You don't want to wind those things together and have to unwind those like I did a few weeks ago. So
let's start with inductors. There's two different types of inductors. There's iron core. There's more, but iron core and air core are the two most common in crossover design. Let's talk about what an inductor should be used for, why we would use one, and what its purpose is, and why we might use an air core over an iron core inductor, or vice versa.
Well, you'd use the air core over the iron core if you like to spend money.
That's true.
That's not totally true. I've used air cores and they do have their place, but they increase in cost significantly over their iron core counterparts.
Yeah, so the iron cores are going to saturate a little, or I've heard will saturate a little sooner, if I'm not mistaken on that. But if we're going to talk about first order crossovers, we would use an inductor on our woofers to roll off the high frequencies. That's the simplest way. I don't want to get into second order yet, as they may have different functions there. But let's just say that an inductor we use simply to roll off the high frequency away from our woofer, where we'd want to cross it over at.
So, yeah, and that's exactly right. So basically what the inductor does, we're going to choose an inductor value based on our woofer's impedance and frequency response. And that's going to limit or get rid of the high frequency. Now, depending on the order of the crossover will be how fast that gets off. Now, when we talk about how fast it goes off, we're going to be talking about how many decibels per octave. An octave is doubling of the frequency. Okay.
Yeah.
So 100 hertz to 200 hertz, for example. So if we said a first order crossover is a 6 decibel per octave slope, that means that it would be 6 decibels down from the first octave of the crossover point. So if the crossover point's 100 hertz, 6 decibels down at 200 hertz.
Yep. Yeah, that's exactly right. And just since you held them up, most commonly an iron core inductor or that steel laminate core is going to be used in a woofer circuit just for traditional reasons. You might get bullied if you use that in your high frequency circuit, but they're really good for woofer circuits for sure.
Yeah,
Well,
Capra asked that question basically, and I was just going to say that it doesn't technically make a difference, but because woofer circuits generally require a large inductor, the cost gets crazy for an air core.
Yeah.
So people generally, if they're going to skimp on an air core, they're going to skimp on it in the woofer circuit because, you know, it's usually going to be like a 3 millihenry inductor or something like that, versus the second pole in a tweeter high pass is going to be maybe a half or a 1 millihenry inductor. So put the air core there.
Or even 0.1.
Yep.
You just never know. Yeah. So, I mean, it's much, much smaller is the whole point. And you're absolutely right. That's exactly what I was going to talk about too. Typically, when you're looking at iron core are usually used in the woofer, and it's mainly cost savings, because when you're buying, say, a 4 millihenry inductor versus like iron core versus an air core, that's a huge difference in price.
Yeah.
When you get into the bigger values, the price difference and size difference can become significant. These steel laminate cores can remain relatively small compared to what you might need on a big air core.
Yeah.
So this is a great question, and I think this is a question that a lot of people have. Does the higher gauge inductor, and by the way, every crossover component, before we go to higher gauge, has a wattage associated with it. Actually, it's usually a voltage. A wattage for resistors, voltage for capacitors. But does the higher gauge inductor in low pass and high pass make any difference in sound quality? So what he's talking about is when you're looking at these inductors are made of wire, and see that this one looks like a donut. So that's an air core. And then the iron core is right here, and it's wired around an iron core. That's made out of wire. Now, that wire can be different gauges. It can be much thinner or it can be much thicker. Now, the question he has, and I'll let you guys fight it out, does it make any difference in sound quality? Or why would you? I'm going to actually change his question because I think it's a better question. Why would you choose a higher gauge inductor?
Ryan, you tackle this one.
Okay.
So you're gonna go ahead.
Basically, an inductor is a bunch of wire just wound up. Like, people make their own inductors. It's really easy to do, actually. If you can measure inductance, you can just wind up a bunch of wire. It's got to be coated so it doesn't short circuit, but you just wind it up. So an air core inductor, because it doesn't have that iron in the center there, it takes more wire. All right. So you get a bunch of resistance, because if you were to unwind that thing, you'd have lots of wire. I don't know how long, like
20 feet, 30 feet.
20, 30 feet of it, depending on the size of the inductor. So you can use a lower gauge, like a thicker wire, to counter the resistance of that long piece of wire. So I would say it does make a difference to have a thicker wire, because your resistance is going to be lower. So especially if this is on the first pole of a woofer low pass, you don't want resistance, because generally your sensitivity is most limited by the low frequencies of your woofer. So if you have a high resistance inductor, you're taking away sensitivity. On the tweeter, it might matter less, but on a woofer circuit, I think it's going to matter quite a bit. So that's why a lot of people go with the iron core, because it requires less wire, so it's cheaper to manufacture.
Really good
Now,
explanation.
Another reason, by the way, if you're wondering what the resistance of, first of all, your inductor is, go to a page like Parts Express or wherever you're buying your crossover components from and look for DCR. That's going to stand for the DC resistance.
Yes.
And that's what,
Yeah.
yeah. And that's going to give you that answer. Now, the other thing, and by the way, in crossover simulations, a lot of people don't realize this. So, for example, XSIM, which we all talk about using, you can put the DCR in and it will show you how that might change your inductor.
Yeah, you can pull that up in the specs of a Parts Express page. It'll give you the DCR, and that's labeled ESR within XM, equivalent series resistance.
Now, the other reason why you might want a smaller gauge or a larger wire cord is it can also usually, depending on what you're using it for, take more wattage. So depending on what you're doing, the wattage might also be a reason why you might want to do that.
Good point. Yeah, maybe stay away from a really like an 18 gauge air core inductor if you're doing pro sound reinforcement or something like that. Burn it out with 200 watts running through it, maybe. So
Yeah.
Oops,
Yeah,
I meant
sure.
to.
yeah, you can test resistance with DATs. You can test resistance, capacitance, and inductance. It's really great for that, and they're really accurate because you calibrate your DATs each time that you use it, and you can actually see the calibration measurement. So they go down to like the 4th decimal place or something.
DATS is like the best, cheapest piece of equipment that you can buy. Like it really is. I like DATS V3, not necessarily this one. This one, by the way, you're going to see on the channel soon. DATS LA. This is the new one. Oh
I
yeah,
want
that.
loudspeaker handle.
I'm excited about
Well,
that.
you can't have it.
I needed that for my Dayton build. I needed more
Oh.
oomph on the impedance test.
I know, and there is a reason why you would want that. But before we do that, but you can test each capacitor, each inductor, each resistor, and you can even tell if it's within spec of what it's supposed to be. Now that's really important because one time I got an entire build done, brand new Auden capacitor. I might be saying the name wrong. But they're not cheap capacitors.
No, yeah, they're expensive.
And I wasn't getting any sound on the tweeter. I was like, what the heck's going on? What is going on? And I'm checking all my solder points, checking everything. I was like, I don't understand. So then I started testing each component. Sure enough, completely shorted out dead on arrival. Like, it happens. I mean,
Yeah.
it happens. So, that's like saved me a whole lot of time because otherwise, I mean, I'm like taking the other crossover out of the other speaker.
Was it an
testing that,
inductor
because I didn't.
that was short?
No, it was a capacitor.
Oh, really?
The first capacitor, yeah. I know it seems odd that a capacitor would be that way. Yep.
Yeah.
Yeah.
Yeah, you got to be careful with inductors, just so people are aware. Like I said, it's just a bunch of wound up wire, and it has a coating on it. That red enamel coats it so it
And-
doesn't short. But if that is scratched when it's getting put together, it'll short circuit, and it'll like short out half or maybe all of the coil, and then it's
And
useless.
The other thing is people will cut these down and they'll try to solder to the red.
Oh yeah, you can't do that.
Yeah, because then they wonder why their circuit's not working. Well, that's why. Douglas Wood wanted to ask about ESR, so thank you. So that's great.
So
There
another-
was a question
Let's-
in there.
Before we go to the questions,
Okay.
we talked a lot about inductors. Before we keep going on, let's talk about capacitors and what their role is. We'll just leave it to the first order once again. And with a capacitor, you will notice that some of these will say voltage on it. Like this one says 250 volts, and you can get some that'll say more or less voltage on it as well. But why do we use capacitors in our crossover? At least the main reason.
A first order capacitor we would use on a tweeter circuit. Well, not necessarily on a tweeter circuit, but we would use it to roll off the low frequencies. So it would be commonly used as a first order crossover in a tweeter, something like that. To high pass.
Basically, stop the bass from going to the tweeter.
Yeah.
And so this is important to know because a lot of people will do active builds now, which active builds are great. We love active builds. But Ryan talks about this a lot. You got to protect those tweeters from when you turn on the amplifier from it popping the tweeter. And it can do that. It can get a low frequency pop through there that can burn out your tweeter. Next thing you know, you're smelling magical smoke that you don't want to smell.
That's that enamel you just showed us.
Your wife's walking through the door and you're like, man, something's hot. And then you're like, oh, no, it's my tweeter. Shoot. Not what you want. So
Yeah.
when what you can do is you can add a capacitor to your tweeter in series, okay, with your tweeter. So when we're talking about first order, that's in series with the driver. So that means like on the positive leg of the driver. And it will protect it from that turn on pop. Now that does have to be a high enough value that it doesn't affect, it has to be a low enough value that it doesn't affect the frequency response, but also a high enough value that it still protects the tweeter.
Good point. And also in audio, we're talking about non-polarized capacitors. That's maybe an important point for a beginner.
Yeah,
if you're
that's
shopping,
important.
it needs to be non-polarized.
which costs more. Yeah.
Yeah.
Just
Oh,
for
that's a great
people
point.
for people who do want to use active crossovers and want to protect their tweeters, especially ribbons and things like that. A good rule of thumb is like, well, I guess it's not a rule of thumb. It's just I'm just going to give you a value. Somewhere between 20 microfarads and 40 microfarads is probably a good starting point for a ribbon that you would cross at like 2,000 or 3,000 hertz.
30 is the right number.
Yeah.
I'm joking. I'm joking. You said somewhere between 20 and
20 and 40. Yeah. Okay. Yeah. Right. 30.
30.
And you
somewhere
can
between-
use XM if you've taken a measurement of your tweeter to go ahead and simulate and make sure it's not going to alter your response, so that you're still measuring your full tweeter's range of play, so it's not affecting the passband.
Brian
Yeah,
Rollerson said he had the exact same Oh, I'm sorry. Go ahead.
I was going to say, if that sounds like a big value, it's because I'm placing that in the stop band, right? I don't normally on a tweeter, you would maybe use something like 8 microfarads, but then it's actually going to influence your frequency response. So that's why it's kind of a big value.
Yeah.
Yeah, you don't want it to influence. Yeah, you just want it to stop the bass from getting in there. So basically what a capacitor's whole purpose is to stop the bass from getting to the tweeter. So it's basically like stop. Now, a resistor doesn't care if it's high or low frequency. A resistor resists everything. And so that's why we usually use that for one of two things, either taking care of impedance or lowering your actual like driver matching, level matching. So bringing your tweeter level down to your woofer. One of the things that I absolutely want to make sure that we talk about is where you place a resistor in your circuit, because I know a lot of people want to, and I get this question a lot. I don't know if you guys have ever heard this. Someone says, I have a 4 ohm subwoofer or woofer. I want to add a 4 ohm resistor in front of it to get it to be 8 ohm or whatever.
Yeah.
Yeah. Why
do
wouldn't
that.
you do that? Why wouldn't you?
You're going to be dissipating the full range if you place it in front of it.
And heat.
Yeah. All that heat, all that energy is going somewhere, and it's going straight into that little resistor, which probably has only passive cooling. So, yeah, you're going to burn that puppy out. You want to place the resistor after your filter, so that you're only attenuating those frequencies that are being played by that driver versus the full range that the crossover circuit will see as it enters. So,
Yeah. And
Hey guys,
if you're
we do. Oh, keep going.
if you're doing that to like protect your amp or something, because your amp is rated for 8 ohms, it's going to be happier playing 4 ohms at a suitable level than you cranking it up, like blowing all this wattage through a cooking hot resistor. Yeah, it's very counterproductive to put a resistor like that.
yeah. Someone asked, Nick, did you have something?
Well, I was just gonna say we are gonna get to your guys' questions as we go too, so don't be afraid of that. We are getting them. Go ahead. You had one that you wanted to ask. Go ahead.
Yeah, someone asks, are capacitors and inductors directional? I assume they mean like polarized. If they mean directional in that sense, no, you should be using non-polarized components. So, yeah, go ahead.
I was gonna say be careful because there are directionalized capacitors, but if you're using them for a crossover, you should be using non-directional.
Exactly. Yeah, if you've got a crossover component, you can assume it can be wired up in either orientation. There should not be a technical positive or negative side of that component.
Yeah, the reason why isn't because like the current's flowing a certain way or something. It kind of is, but a sine wave goes positive, negative, so it's actually an alternating current. Just like what comes out of your wall is 60 hertz. If you live in North America, it's going up and down 60 times a second.
Wow. Already learning the North American stuff. All right.
Coming from 50 hertz land.
No, we had 60 hertz.
Oh,
in
really?
Canada.
Okay.
Oh,
Yeah.
That's how much I know.
Canada is in North America, you guys.
That's true. That's true.
Well, you did say North America, and after I said it, I was like, oh dang, he said North America.
So yeah, it's going up and down. So that basically means it's going back and forth through that capacitor. Now an inductor, again, it's just a coiled up piece of wire, so it has no problem. Current can pass through it back and forth, back and forth. But a capacitor, depending on how they're designed, because there's very different ways of constructing a capacitor. We need the non-polarized one so that it can go back and forth.
And that is something that I wish more people would talk about, because when I got my first speaker kit a long time ago, they came with a diagram that like showed you exactly how to wire it. And these air core inductors, I was making sure to wire like the middle portion in the right spot from the outer portion, because I didn't know any better, right? Like I'm looking at the diagram, like, okay, which one does this go to? Okay, it goes to the middle one. Okay, this one. And like those are things you just don't know when you first start.
Absolutely.
Oh, this is an interesting. What do you think
No,
about this?
don't. No.
I think we were all looking at that.
A-Dubs says no electrolytical in the crossover. So let me get you. I have an electrolytical right here. Let me show you the difference. You guys talk about it.
Okay. A-Dubs.
Any
Sorry,
Ryan,
I
have you ever
disagree.
used any?
Oh,
It sounds like you have, yeah.
Lots. The only thing I understand to be bad about them is they can drift over time,
Sure, yeah.
which is a problem. So depending on everybody, when you design a crossover, now this is for advanced crossover designers, you should do a sensitivity analysis. Anybody in the engineering world knows to do this. So if you're designing, say, a structural member in a bridge, you're going to do a sensitivity analysis in your software. You're going to increase the load, you're going to change the location of the load or whatever, and see what that member is doing and see if it's happy or if it quickly goes out of sorts. You should do that with your crossover as well.
And your drivers.
Yeah, if I buy an 8 microfarad capacitor and I get a 9, what's going to happen? If I get a 7, what's going to happen? Okay, so you can just, in your software, you can just tweak those back and forth. Go ahead and buy the 8. If it's a really sensitive value, buy a high quality capacitor. If it's not, if it doesn't make much of a difference, but you need that component there for something, you can probably get away with electrolytic.
Yeah, one thing
real quick, that's a good point. If you look at like the capacitors, you're not going to be able to see this on this particular capacitor, but it says it's brand Dayton Audio, 4.7 UF, 250 volts, and then this one says 1%, which means that it can deviate, or it should deviate about 1% of whatever its value is, 4.7. Now this one over here, for example, says 5%. There's some that will say 10%, 1%. You obviously pay more for the 1%, 5%. Now this is an electrolytic. It looks different. It's gray.
It's a big value.
Lettering.
Too.
All of them look, it's 68 UF. Because I only use electrolytic in two situations. Cheap speakers, like small desktop speakers that, or if they're going to ground. And when they're going to ground, I use electrolytic because it doesn't matter nearly as much. But sometimes you need a large value capacitor, and electrolytics are much cheaper if large value capacitors than.
Yeah, like if you need 100
color
microfarads or something, it can
You
get
want to go
expensive.
electrolytic.
Yeah.
One other thing is electrolytics are often for the equivalent value may have a higher resistance. So a typical capacitor may be somewhere, could be really low, where an electrolytic could be 5 times or 10 times more than what you're expecting. So if you're just replacing parts haphazardly or upgrading, as they say, your components in your crossover, and you don't have any way to simulate that, use the same manufactured type of components. Don't go putting an electrolytic or swapping a film capacitor where an electrolytic capacitor was, or at least know that there's consequences for doing that.
Yeah.
Dan Russell said something pretty interesting. I don't know anything about this, but he said 2 electrolytic capacitors can be wired together for non-polar use. I didn't know that.
Yeah, I think it's because no one does that, Dan. It just doesn't seem worth it.
I've heard that. I've definitely never done it, but I think I've
Yeah.
read that.
It's
All right,
like
this.
just buy a non-polarized electrolytic. I don't know.
This is a great question. Oh, not this. This is not a question. You guys are talking too fast. All right, here's a great question. How do I know how many watts a crossover can handle or is rated for? And how can I design based on power? Thanks and hello. Well, hello, Subdenomen.
Subdiminum.
Subdiminin. I'm just gonna call you
Subdino Man.
Yes, we're gonna
Oh
talk
yeah,
about El
yeah, yeah.
Paso.
That's it. That's it.
Subdino Man.
That's it.
No, it's cinnamon.
Yeah.
Well, after you get done dancing, cinnamon, we'll tell you. All right. How do I know how many watts a crossover can handle? No one wants to tackle. I mean,
I'll do it.
Yeah. Okay. Go ahead.
Whatever. I don't know. One of you guys.
We've covered part of this, but go ahead.
No, I think it's important, especially with resistors. I think we should talk about this.
Yeah, I think it basically boils down to the resistors. I think most, even $1 capacitors are going to have enough voltage. They're gonna be able to handle most of the power. The inductors, like Cameron said, maybe if you're in a pro audio setting and you're using really cheap inductors, you might melt them. But generally, resistors are like 10 or 12 watts rating. So generally, we only use those on the tweeter section. Well, I shouldn't say only. Definitely use them in a woofer section, but
and mid-range maybe.
Yeah, but they don't see a lot of power in the woofer crossover because they're usually on the second pole or whatever, or on a notch filter or something like that. A lot of crossover design software, you can actually look at the power input on each component. You can just tell the software, okay, I've got a 100-watt amp or something like that, and you can look at the power dissipation on each component. But generally, it generally boils down to your L-pad on your tweeter, and especially the series resistor, assuming you have a conventional L-pad of a series resistor followed by a parallel resistor. And so I will often take 2 or even 3 resistors and wind them in parallel together. So say I need 5 ohms on my tweeter, I will take 2 10-ohm resistors, because if you're using 2, you can just cut the value in half, wind them together, and then you kind of get 20 watts of power available from that. And if I really think I need a lot of power, then I'll take 3 and put them together. And for that, there's a form. Yeah, or 4. I've actually done 4. Or if I'm testing and I need parts, I'll take what I can get. And yeah, there's a formula for that. If you're using 3 or more, it's like 1 over R1 plus 1 over R2 plus 1 over R3 equals 1 over R.
There's also just free calculators, which is better to use.
I don't use those. I'm old school.
And those are using the formulas themselves. Yeah, great point. And that's to share. They're all sharing the load that tweeter is seeing, right? So that you're spreading out the wattage over more resistors, so that it's not all heating up one single resistor.
Now in XSIM, there is a graph for that. You can go to Add Graph and go to Component Power Dissipation and select the component, and it will show you the power dissipation. This is where we should really talk about where the resistors should be placed in a circuit. So many times do I see people place things incorrectly. Like we talked about, like the resistor in front of a woofer. Resistor in front of a woofer should never be the case, especially it's going to see all the power, everything, because it's before every crossover, right? So it's going to see everything from, I don't know, let's say 20 hertz to 20 kilohertz. It's going to see all of that. So that's a problem. If we put it in front of a tweeter, a little less of an issue there, but the best place typically for an L-pad is going to be after the crossover circuit of the L-pad. That way, the resistors only see the power after the crossover point.
Yep. Yep.
Which on a tweeter is going to be significantly less than it would be if it was on a woofer.
Yeah, substantially less. Subwoofer Dino Man says subwoofer dynometer man. LOL.
We were way off.
Now we figured it out.
We weren't even close.
Let's see.
All right, so here we go. This is a good question. This is by Brian Rollerson. He said, what order would a high pass with an L-pad be?
If you're talking about a first order crossover with an L-pad in addition to it, it would still be a first order crossover. That's the electrical and acoustical roll-off, where a single resistor, or rather an L-pad, is going to attenuate the entire range, and it's not going to affect the acoustical roll-off per se. The series resistor can shape it in some ways, but it's not going to add to the order of crossover.
Yeah. I think this just to say a high pass with an LPAD, there's no way to know what order the crossover is. Basically, when it comes to a high pass, you're going to have a series capacitor with a parallel inductor with a series capacitor with a parallel inductor with a series capacitor with a parallel inductor as many times as you want. And every time you add a component, you're adding a pole, you're adding an order to your filter.
6 decibels an octave.
Yeah, in theory. It never works
Well-
out exactly to 6, but yes. So if you just have a capacitor, that's a first order high pass filter. If you have a capacitor and an inductor, now you have a second order, third, fourth, fifth, sixth, and so on.
And the value of those will change. So those are textbook when we say first, second, third, the number of components. We can talk about those orders describe the rate of roll off that you guys were describing. And so as we change those component values, those can also affect the order too. So you can get higher than second order roll off with a second order filter, depending on the value of those components. So,
Philip, I'm so glad you asked this question because I brought it up prior to going live. And yes, I did, kind of. And the guys
you did.
The guys were like, "Oh, I don't know if we want to go that deep."
I said I don't think we'll get to it today. I was wrong. All right,
I actually just described this as you can get higher order rates of roll off.
So let's read Philip's question first. Just for anyone that might be listening on the podcast, do you ever try to make high order slopes with lower order networks to save money / components? Are there any drawbacks to doing that?
Thank you for reading it out. I forgot that some people just listen in. That's terrible of me.
It is.
Yeah.
No, it's not. So anyway, so go ahead. You've been waiting for like an hour.
Okay,
to
I get to answer this one. I feel like I'm hogging the show. I'm sorry.
No, we want you to hog it. Do it.
So Philip, absolutely. It's not really something you can control though, okay? Because what happens is your drivers will already have their natural frequency response shape. Okay, so a tweeter is a great example. A tweeter is a very, very small driver in a sealed box. So it generally, unless the box is very small or very large, it generally has a 12 dB per octave roll off, somewhere usually around 1500 hertz. Typical dome tweeter, okay? So if you add one capacitor, what are you laughing at me? Sorry.
I just remember when we were texting about dome components and I accidentally texted dumb components. And
yeah.
And you said dumb tweeters are my favorite or dumb
yeah. All
Sorry.
right. Inside joke.
Inside joke, yeah.
So yeah, back to the thing. We've got this 12 dB per octave roll off on our tweeter, around 1500 hertz, let's say. Now, if we add a capacitor to this tweeter, we're going to assume impedance is perfectly flat and there's no hanky-panky going on. So we've got this. So we've got this 12 dB per octave roll off. We add a capacitor that puts an extra 6 dB per octave transfer function on the frequency response. So now that tweeter is rolling off at 18 dB per octave. That's a third order acoustic roll off. Okay, let's go to second order on the tweeter. Now we're getting another 6 dB, 12 dB transfer function on a 12 dB acoustic slope, gives us 24 dB per octave roll off acoustically. Now we have a fourth order acoustic roll off on that tweeter, and we've only used a second order crossover filter. This is what you're normally going to see. You're going to see this often, and a lot of my designs will be a single order filter on the tweeter, or maybe a second order filter on the tweeter, with a third or even a fourth order tweeter, third or fourth order filter on the woofer, because the woofer tends to climb as you go up frequency response. So I need a sharper transfer function to get that thing into shape.
Yep.
So
yeah,
that does somewhat depend on where you cross over the tweeter at.
That's
absolutely.
a good point.
Yeah.
The situation Ryan was describing is where the tweeter naturally begins to roll off or climb up, depending on which direction you're looking at it. And so if you're wanting to cross it, let's say you're designing a three-way and you're going to cross it way higher, you might need a higher order filter in order to roll it off more quickly when you're not using that natural roll off.
I will tell you this. my favorite order on a tweeter, I don't care. I almost always use a third order on a tweeter.
Really?
Oh, yeah, I do. I do. For a lot of reasons. One, to keep the tweeter out of the woofer range, although I like to try to run my tweeters lower if I can, especially if I'm doing a two-way with like a bigger woofer, right? But the other reason is to keep, I know you don't care about distortion, but I do. Distortion out of it. And so, out of the crossover region as well. But yeah, my favorite crossover is second order on a woofer, third order. Of course, it depends on the woofer. Obviously, if we're talking about, one of these aluminum woofers like we were talking about last week, then that might be different. But if I can get away with second order on a woofer, I try to use that, and then third order on my tweeter. It's like my favorite, and almost in a lot of my designs, you'll see that.
Yeah, especially if you're crossing woofers over lower, it's quite likely you're going to have to go to higher orders to get the roll off that you're looking for.
And that's what we should talk about. So there are differences between first, second, third, and fourth order crossover points. Some of it has to do with phasing. Some of it has to do with how steep the slope is. Now, the steeper the slope, typically, the later, like on a tweeter, the earlier, I guess, you can cross over. Or on a woofer, the later you can cross over. So, meaning in frequency response. So, the later in frequency response on a woofer, earlier in frequency response on a tweeter. That can be more for protection. So, some people will do that for protection of a tweeter or a woofer, or to get unwanted sound out of the frequency response as well. Some people will go to fourth order. I don't do a lot of fourth order. Do you guys do a lot of fourth order? Fourth order adds a lot of complexity and cost.
Yeah.
I've not done fourth order analog crossovers, passive crossovers. Certainly active, but I've never been able to pull the trigger on designing a fourth order passive crossover.
And if you do that sensitivity analysis I talked about, the more poles on your filter, the more they all interact together. So you'll do that sensitivity analysis and things will just go haywire for every component. So you got to be careful with that.
Yeah, it's a lot trickier to implement. The higher the order you go in general is trickier to implement. So just keep that in mind. This was a really good question. Oh, and phasing also. The least amount of phase shift happens in a first order. The most amount is a fourth order, which is 360 degrees, actually. And was second order 180, right?
Yes.
Third, I don't. So I guess third is 270.
No.
No?
180 total, both sides.
Right.
90. Yeah, okay. Yep.
No, why don't you explain it better? You're breaking it down better than I did.
I'm having a brain fart, but it's 45 degrees per pole. Am I right? So if you have a second order filter on your tweeter, that's 90 degrees of phase shift.
So 45 per component.
If you put a second order filter on your woofer, that's 90 degrees of phase shift in the opposite direction. So total is 180.
Which is why a lot of people ask the same question, which I think is really important with crossover. You'll see the designers say on your tweeter, for example, and it really doesn't matter. If it's a two-way, it really doesn't matter if it's a tweeter woofer that you change or mid-range that you change. But they'll say reverse the polarity, or the positive goes to negative, the negative goes to positive. And they do that because of the phase response.
Yeah.
Which is totally natural. Someone asked, are those changes natural? And yes, those are just inherent problems in when it comes to putting components in the signal path, which can be corrected either by higher order or equal order filters, or like Nick said, reversing the phase or the polarity of your driver to get them back into phase.
I got to say something about phase, because phase is really tricky. We're not going to get into phase and why it happens and what to do about it and everything. But can I just say, people make way too big of a deal out of it. The reality is, getting your frequency response right, getting your off-axis response right and everything far exceeds the sonic qualities of trying to get as little phase shift as possible or anything like that. Like if you're sacrificing...
You're talking about in the crossover region?
Yeah, exactly. Like whatever you got to do. I mean, I've heard of people like, oh, I wouldn't use that notch filter because it introduces phase. I'm like, but there's a 6 dB peak in the response that I got.
Which one do you care more about?
like, stop worrying about phase so much. If phase will happen, you'll have to deal with it. You'll have to tweak your crossover to make sure both the drivers sum together nicely and everything. But if it sounds better with a fourth order crossover, which is 360, 180 degrees on both sides of phase wrap, then do it. Like, it'll sound better if it's a better response. You know what I mean? So
I will say this though too. When you're designing a crossover, don't just go off your simulated response. I see that way too often.
yeah.
People will take the simulated
Check.
response, look at it. Well, not only double check, but also listen to it. Now,
Yeah.
I know I've created, for example, some notch filters that looked beautiful on their response. I'm like, this is gorgeous. And then I listened to it with and without it, and I was like, you know what? I actually like it better without it. And, you know, that happens sometimes where, believe it or not, it might look better, might even like measure better, but when you listen to it, you're like, nah, there's something else going on here. So, you know, just think about that as well. That's why Ryan said, be slow to put your crossover together last week.
did I? Okay.
Yeah, remember,
That's how bad
'cause
my
I was like-
memory is.
Yeah,
Remember,
yeah.
because I said it would be great. No, I don't mind. You can do it fast. And you're like, you're wrong.
Use alligator clips and listen. We do believe in software on this stream.
Oh, absolutely. Yeah.
But
yeah.
the ears are the final judge.
Yeah,
I believe, for each of
absolutely.
us.
Absolutely.
So,
And
All right.
I'm all about like tweaking and trying to deal with phase. I'm just saying, especially if you're starting out, just try to get the basics, like frequency response and off-axis response and stuff. It's the most important part. Worry about that.
agreed.
Um,
I'm
read it
not
out.
sure. I don't know what he's saying here, so I'm wondering if you guys understand what he's saying. Before adding a Z offset in XSIM, so he's got his two drivers in XSIM. He's got a tweeter and a woofer in XSIM. I can see the phase change at the crossover frequency, but after adding the Z offset line and adjusting the value to match the combined parallel response, I see that there are multiple phase changes in the response. Is that normal?
Okay, so when you change your Z offset in the software, your phase is going to move.
Right.
It's going to move around because I've said it on this podcast before. Time, distance, and phase very closely interconnected. They're interchangeable. So offset is distance. You're changing the distance. Lots of software will let you do it in milliseconds. Guess what? That's time. That's a unit of time. You're changing the time. You're changing the distance. You are changing the phase. So if you change your Z offset, expect your phase to change. I don't know if that's totally answering his question, but that might be
So
related.
technically, it's normal, and if I'm not mistaken, I might be wrong. Ryan, don't you just shut off the phase anyway when you're designing the crossover?
No, I'll leave it on. Maybe not at first, but I'll turn it on eventually because I'll turn it on for the individual drivers because then I can see like, oh, they're 20 degrees out. That's why I'm not getting good summation. And it's because the tweeter is leading the woofer or something. So I'm going to do this to the crossover to punch it that way or something and get better summation. But
Yeah.
it's not wrong to leave it off. Like, ignore it. If you're starting out, don't look at the phase. Just ignore it.
Well, and you can also check as if, for example, you can see how many decibels down at your crossover point you are from your frequency above, and that should give you a good idea if you're in phase or not.
Yep.
If you're about 6 decibels down, you should be in phase.
Yeah. That's what the reverse null is for. We've talked about that too.
Yeah.
Yeah,
flip
you can do the reverse.
polarity.
Yeah, but we talked about that last time too, where people are so concerned about that.
Yeah, don't
The
worry about
depth.
the depth.
The deep-
worry
the
about the,
depth of the
breadth.
reversal.
Yeah.
Yeah. So another angle to try to answer this is, if your crossover point doesn't change, or if the reverse null on your crossover point doesn't change after you enter the Z offset, then you've got a point source driver. So
Say that again. If his
Yeah, so
Yes,
so what
if-
he's saying is if you take a measurement of the woofer and a measurement of the tweeter, which this is how you typically take the measurement for a crossover. You take the measurement of the woofer, the measurement of the tweeter, and then you take them together in parallel. If when you import
Oh.
that parallel line into XSIM and it looks exactly identical
it's
to
already
those
right.
two,
Yeah.
Yeah.
yeah, it's already in, and he's right.
Yeah, then you don't need to change that offset.
That's a great question. And there are I have one right here on the ground that I would love to show you, but I can't show you it yet. I'm not allowed to.
Oh, teaser.
I know. It's a new driver by a very well respected company. You're going to see on the channel. It's really exciting. I think you guys are going to like it. But I haven't tested it in that, but it's supposed to be what we call concentric. That's what we call a concentric driver, meaning that the sound comes out both at the woofer and the tweeter at the same exact time, which means we talk about this a lot with a two-way design. Your tweeter here, woofer here, you get great horizontal off axis, but when you go up and above it, that's going to change. And we're going to get some null in the frequency response because of that. And that's just typical. But with a concentric driver, because it's the sound's coming out the woofer and the tweeter's directly in the center at the same time, well, now should have the same response above as well as on the side for that particular part of the frequency response, whatever that's crossing or playing.
Yep. Yep. Very cool. Lots of use cases for concentric drivers, and perhaps help simplify crossover design.
Now, we do want to go more in depth in crossover design, but someone had asked earlier, and I really think we should get to it before. They said, can you explain LPAD stuff? Which I think it just means in general, like how does an LPAD work and
I missed
when do
that
you use
comment.
it?
Yeah.
Yeah. So when would you use it, Cameron?
So we use an LPAD to attenuate. So when we're trying to lower the level to, I think it was mentioned on this episode already, but generally our woofer is the lowest in sensitivity, or it should be, so that we can attenuate, because we don't want to have to attenuate our woofers. There's going to be way too many problems with that. So we want to attenuate our tweeter down to our woofer's level. So we'll put a resistor in series with our tweeter, and then we'll put a resistor in parallel with our tweeter. And as we adjust those values, we can lower or attenuate our tweeter's response.
Or shape, even shape.
Yeah. The series resistor will shape. I think I mentioned that. So that can actually roll off your top end and lower end. So be careful as you play with those values. Watch your response.
Yeah, if your response starts to look like a sad face, then it's something going on.
It's called an LPAD because it's a resistor and then a resistor, like an L.
Yeah.
Kind of upside down.
It's an upside down backwards L.
So,
yeah.
also because you might be seeing this differently, it would be the series resistor, and then it would be the parallel resistor right before it connects to the driver. So the parallel resistor would be the last resistor before it connects to the driver.
Yeah, you can basically solder it right to the terminals if you wanted. It would be.
And I'm just making sure, because I'm not sure if we're backwards to them. Like if it looks like the resistors before, it's after. It's the last component.
And as you raise and lower that parallel value, that's what will attenuate the entire frequency range of your tweeter or whatever driver you're using the LPAD on. It could be a mid-range and a three-way. You can do an LPAD there in some cases. So.
And you can attenuate your tweeter. There are other ways to attenuate tweeters as well. I have a whole video on 3 different ways to attenuate your tweeter, including playing it underwater.
Oh, that would do it.
That'll do it.
No, there is definitely some good stuff there, but yeah, an LPAD is absolutely instrumental, and the biggest reason why is your drivers are going to be different sensitivity, meaning that the amount of wattage going to each driver is going to play at a different level, and your tweeter is almost always going to play at a higher level than your woofer. There are some cases where that's not the case, and that's just you just need to scrap that design.
Yeah,
that's an issue for driver selection, which I think we did a few episodes back. Make sure you're choosing
Brian Rollerson says, use silver or gold unless you're an audio peasant.
That is totally true.
Yeah.
On the LPAD thing, I'll just note that the parallel resistor, if you just had a parallel resistor, you wouldn't see attenuation, because you would just dump more power through that circuit to try to make up for the reduced impedance. So it's important. They have to work together, and they do different things especially because of tweeters. Maybe I'm trying to explain something that just can't be done
No,
in this
you're
setting.
good.
But yeah,
You're
the
good,
tweeter impedance, because of its shape, when you put that parallel resistor in there, it's going to nip off the resonance frequency and the inductance as you go up in frequency. So that helps the series resistor do its job better. It also helps your crossover do things better, because if you put, especially an aggressive LPAD in there with compression drivers, I love using a really aggressive compression driver because you need to get the sensitivity way down. But doing that means you're basically, for the cost of a couple of resistors, you're flattening that impedance curve, and then your crossover components have much more freedom to do what they need to do.
Great question. Great point. Now, here's another question. What role do Thiel's small parameters play in crossover design? This is, you know what? I have never heard anyone ask this question, but if you're beginning, I think this is a good question
This
because
is a fair question.
I think so. Yeah, I agree. So, who wants to answer?
We're going to let Ryan answer this one.
Well, no, I feel like I talk too much.
Go for it again. Unless Nick wants
IHOR,
to take it.
IHOR, lower.
Pete
Yeah, sounds
Pete Licky?
European
I
or
don't-
something.
I don't think it's Pete
Anyways,
Licky.
anyways,
Pelic.
Mr. Pete, they basically have no role. They are for box design, so they really characterize the very low frequency characteristics of the driver and how they'll respond to being enclosed, or loaded into some kind of vented box of some kind or something like that. But in terms of crossover design, we don't consider the TS parameters at all.
Yeah, the TS parameters describe the movement and the force of the driver, which is relevant in designing a box, as Ryan said. We're simulating the acoustic response, which is beyond metrics like that. So, yeah.
All right, now we have one other question I thought was pretty interesting. This is by Phil. Oh, Brian
thank
Rollins
you.
put a super chat. Thank you, Brian. Never mind, you may not get your question answered because Brian Rollerson is. Thank you, Brian, and he gave us a $5 super chat because he knows we are audio peasants because we don't use silver or gold.
Yeah, I know.
He said, "What is the effect of adding a second woofer? Does it matter if it's in series or parallel?" It's
I like
a little
this question.
off topic.
It's a good
I like
crossover
that.
design question because it is relevant here.
Cameron, you
Well,
just
there's-
did a 2-woofer speaker.
Yeah, I did. Yeah, sure did.
I haven't talked a lot. I'll
Yeah,
answer
no,
this.
okay, Nick, sorry.
No. There's quite a few things that can change with adding a second woofer. I'm going to make the assumption, first of all, that we're talking about them both playing the exact same frequency response instead of like a 2.5 way. So this will be a 2-way. And I'm also going to assume that we're talking about like a TMM, meaning the tweeters above with 2 M's or 2 mid-ranges or 2 woofers below. Two things are going to happen. First, we're going to change our impedance. That's going to be the number one thing. And maybe even our sensitivity. Theoretically, if we're going, say, 2 8-ohm woofers and we're wiring them down to 4 ohm, then we would actually get a theoretical 6 decibel boost in sensitivity. 3 decibels for the woofer, for the added woofer, and 3 decibels theoretically for the impedance decrease. So going from 8 ohm to 4 ohm. Okay. I guess it's technically an increase, but you don't understand what I'm saying. So that's going to be the first thing. The other thing is, believe it or not, the center of where that sound is coming out has also changed for your crossover design. And with the crossover design, that's where it's going to be most important. And this is why some people don't like TMMs. I actually don't mind it because it's really only going to affect, well, if you cross over low enough, it's going to affect a vertical offset more than it's going to matter with your horizontal. Basically, your new center of those two drivers is basically going to be in between those drivers. So no longer is your acoustic center the middle of each driver per se. So those are going to be the two main effects that it's going to have on it.
Yeah, we here attend the church of crossing over really low so that your vertical doesn't suffer quite as bad, or that those crossover frequencies aren't as big of an issue when you cross over lower like that. You've got longer wavelengths, so I like TMMs for that reason.
Does any yeah, and you can do an MTM if you do an MTM. Once again, the it's still the first, you know, it's whatever's going to be between if they're playing the same frequency response, wherever the center point is between those is going to be, you know, the acoustic of those.
Yeah.
Oh, acoustic center. Oh, okay. What is this?
He
Bose
also asked.
4001.
He asked if it'd be worth upgrading the crossovers in these, and so I see where his question is coming from because there's two woofers and they're probably playing the same band. Maybe they're 2.5 way, or they look like a 1.5 way with kind of this side radiating speaker. I'm not really sure how these are configured.
I would bet it's really simple.
Yeah.
If I'm guessing, you could find out online.
I would probably look at the crossovers to see if there are any electrolytics or any damage or anything, maybe freshen up the existing crossovers. And then I would look into measurement equipment and measure the response in the room to see if there's anything nasty that you need to deal with before going too far.
This is the other effect. And I think that those are probably just playing mid-range. And the tweeter is, Bose for the longest time did a lot of that reflective high frequency, you know, behind their speakers, off the walls. Yeah. So I'm going to assume that those are mid-ranges and those are probably just a two-way design. And so once again, the center of those two woofers, or the acoustic center, would be in between those two. Now that's why some people like an MTM, is because the acoustic center is technically where the tweeter is, but you still have to design that correctly.
We got another really good question, which we didn't cover, which is relevant to crossover design. Is baffle step compensation having an LPAD? And I guess another good question on this topic, although we're past our time limit here, do you guys deliberately add a baffle step correction circuit, or do we let our filters shape that?
I have, in smaller speakers, added a baffle step correction circuit for like little 3-inch full range drivers, versus adding, you know, because you're using the whole full range. So you really need to attenuate everything after that.
Yeah.
So I do on that, but otherwise I don't usually use a baffle step correction circuit. I think me and Ryan would say the same thing. I think you would say the same thing too. Just use your whatever low pass you're doing. Let that affect it. Yeah.
Yeah, so baffle step comes from before we had ability to simulate, and they had to assume that the baffle diffraction was going to occur at some frequency, which it still does, but we can see exactly where that is, and we know how we're shaping it. And LPAD is just specifically for attenuation, so that wouldn't necessarily be your baffle step. That would be most likely in your woofer or mid-range circuit.
Yeah, but you would take that into account in your crossover, absolutely.
Yeah. Definitely.
But you would use your low pass for that. So whatever low pass circuit is going to take into account that. And Brian Rollerson, who did give us a super chat. By the way, Brian Rollerson, he should get like a special plaque or something, being the only super chatter. He gave us a super chat. He gave us a super chat last week too. We should have a monthly, like, this is like the best super chatter. And here it is. Brian is it. Brian wins it. For the month of May, Brian easily wins the best super chatter. But he said, before you guys leave, I wanted to say it was a great show, very informative, well done. And Brian, you are our very first super chatter award. So you get the recipient of Audio Digest super chat.
Month of May award.
May of 2025. Yeah, that's awesome.
Cool.
What were you going to say, Ryan? I'm sorry, I didn't mean to cut you off.
I don't think I was going to say anything.
Okay. Well, guys, he was in awe at the super chatter.
Yeah, I was just amazed by Brian. Gold caps.
You could always see out for some gold caps. He's talking about on our teeth, though. All right, guys, so let's go ahead and end the show. But before we end it, we always talk about what we have coming up on our channel. I'm going to start us off instead of ending us this time. I'm going to let one of you guys end us. So I just finished a really cool projector review of the Nebula X1 projector. I know you guys haven't had very much experience with these new triple laser, what they call them, lifestyle projectors, and technically that's true, but they're home theater projectors. I mean, I don't care what people say. The contrast ratios are getting insane on these things for them not to be considered more than just a lifestyle projector, and this is one of them. I was really impressed with it. I also have two. Oh, Philip's trying to outdo
Thank you,
Brian.
Philip.
Oh, Philip might win the title.
Philip, if
He's
you got a
like,
question,
Philip
just let us
wins.
know.
Yes, absolutely. We'll answer it before we go. Philip with the $10 super chat. Thank you, Philip.
Thank you.
I forgot what we were talking. Oh yeah, so I have two videos coming out. One is actually on the topic we just did, and the other is on the 5 biggest mistakes that a beginner DIY builder makes. It's not the same thing as what we talked about in the show. They are different. Some of them overlap for sure, but some of them are different. So those are coming out. So if you guys are interested in those types of topics, make sure to subscribe and watch those. And guys, comment on the videos when you see them, because it helps other people see them. That's one thing. Even if you have nothing to say, just say hi. They said a lot to Ryan, actually, right, Ryan?
Yeah. I just put up my first video in a long time, and I had a lot of comments just saying, "Hey, welcome back. It was great. Thank you."
Ken Thomas, $10 odd
Wow.
dollars.
We got some
Love you guys,
Aussie
too.
love.
Aussie love. Nice. Them and the Kangaroos. Thank you, Ken
Ryan-
Thomas.
Ryan says they're making him look cheap. Ryan, you spent all your money on gold caps.
Yeah. Honorary mention. Capra Hi-Fi said he tried, so he gets an honorary mention for that.
Okay,
Oh,
and we got
one more.
Prashant
You guys,
Super sticker.
raising his arm was saying, "How's it going?" Nice.
Character lying on the side, raising his arms while saying, "How's it going?" That's awesome. It's going much better now. Now we're gonna have to make everyone an honorary super chatter. Brian 501 will put you over the top.
So, if any of you guys who are super chatting, if you have a question, or if you don't, come back next week and just tap us on the shoulder and remind us. We'd be happy
we
to
remember.
answer it. Yeah, we'll even answer off-topic questions about, if there's something that is really pressing, we'll help you out with that.
Now you said you had. Why don't you tell us about your video that you just put out and what you have coming up?
Okay, yeah, I just put out a video about the Dayton Ultimax 18, the new one. Very happy with it. It was awesome. So it was a very positive review. And I put it in a sealed subwoofer enclosure. And so my room is finally rocking, even though I still don't have a couch. It's not because I just can't afford one or something. I just haven't gone to get a couch. But I do have a subwoofer now, so I can enjoy some movies. And I have coming up, so in that video, I talk about a pesky little 60 hertz room mode. It's bugging me a lot. It's very annoying. So I bought a DSP, and I am going to integrate it and show you guys how I do that and let you know my thoughts on that DSP. Before I launch that video, I'll probably do a short.
That's the 408, right?
Oh, well, I wasn't going to say. But yeah, it's the Dayton. Doesn't matter. It doesn't. It's not like there's a ton of suspense around it. Yeah, it's a Dayton DSP 408, and I'm gonna do a little short, just unboxing it and telling you, it's a very inexpensive DSP. So we're gonna see how it actually performs.
cool.
That is awesome. Yeah. What about you? Oh, before we get to that, Ken Thomas said, I do have a question. He said, lads, would love to get your thoughts on symmetric crossover design. Double the components. Does this provide a benefit? Now, I think what he means by symmetric would be like the same values crossed, like values on one side and values on the other side switched. So like if it's a 20 UF capacitor on the tweeter, it'd also be a 20 UF capacitor on the woofer, obviously going to ground.
Yeah, when I
Ken,
hear
let us know if we're.
Yeah.
Let me know if we're wrong. First of all,
I wonder if
But
you
that's
need
what-
series crossovers.
when I hear symmetrical, it's always in reference to symmetrical slopes, so kind of mirrored slopes.
Oh yeah.
So
Okay.
that you're getting better phase integration.
Oh yeah. So you don't have
oh, here we go.
Yeah.
This is according to AI, a symmetrical crossover design. This is, and you let us know if we're wrong with what we're talking about. Is an audio crossover circuit where the components on the positive and negative sides of the circuit are identical. This design aims to create a more balanced and symmetrical electrical load for the amplifier. potentially improving sound quality and speaker performance. I have not found that to be true.
Yeah, technically you can do that with a crossover, but I agree. I think that sounds like way more work than it's worth. I don't think modern amplifiers care.
Yeah, he says components on both sides mirrored, so yeah.
Yeah, and I don't love that because first of all, it's hard to get the phasing correct with that as well. There are you have to be a lot more intentional when you're doing that with a lot of things. As far even driver placement might be an issue with that as well to get the phasing and everything correct. I don't think it's worth it. Now,
No, I have put a resistor on the other side of the tweeter, so it's in series, but it's on the other side just for like room on the board or something like that, but not because it offers any performance advantage realistically.
yeah, you'll actually if you put this into a crossover design simulator on the internet, it'll give you that. It'll
Yeah,
give
they
you
will.
it'll give you a mirror design, assuming you're using the same impedance
Yeah.
driver. So 4 it will give you a mirrored design. But no, I usually find that not to be as good.
Yeah. Again, don't worry, don't sweat those little details. Like, just focus on getting an extended flat frequency response with good integration, good off-axis response. Stick to the fundamentals that we know make a good speaker. Yeah.
He said the components are half the correct value but doubled. So I got you. So you have 220 UF in parallel with each other to get. I guess I would give you a 10 UF value.
So not on opposite sides of the driver, just like if you parallel
No.
capacitors together, you get twice the value. Is that what he means?
That's what he's saying. He said the components are half the correct value but doubled.
That's
so
true. So if you need a 10 microfarad cap, you can put 2 5s in parallel and you'll get 10. That is true.
But no, that's still not going to make any difference. In fact,
No.
if anything, it could actually introduce more issues. For example, if a capacitor or something were to go bad, you have a lot more things to check. Not to mention, the only time where that might be an issue is what we talked about earlier with resistors.
Yeah, I would
Yeah, the opposite
double up
side
on
with that, yeah.
resistors. Yeah.
Yeah. We're all in a. See, I want to actually talk 2 minutes about this. A lot of this comes back to what I would consider audio foolery instead of audiophile. You'll hear it from like really expensive drivers, speaker manufacturers. This is the way that we design our crossover, and we do it for this reason. It adds airiness, and we have all of these benefits to it, and really it doesn't make any difference. And when we talked about this, they do it in a way that sounds good and it whets your appetite to want to eat more of it, but it's not actually anything that makes any real difference.
Yeah.
Yeah, I mean, they'll go as far as changing the FS of a driver, going to a driver manufacturer, taking an off-the-shelf driver, and having the FS or something modified so that they're able to use a first order crossover in a particular region, so that they can say there are less components in the signal path and la-di-da. And you're getting the same result by using a second order filter where they used a first order with this altered driver. Sure, their method worked, but they spent $500,000 changing the characteristics of this driver and the way it's manufactured just so that they could say they used a first order filter or whatever they're doing. They do a lot of exotic things like that we can accomplish with other methods that are just as effective. And so far, no group of people has been able to meaningfully distinguish between the two. So audibly. So
Now, Cameron, what's coming up on your channel?
I've got a really budget home theater build cooking. Parts are on the way, or crossover parts are on the way. The cabinets and enclosures are already done, already finished. So I'm excited about that. We're going to put them together and listen, see if the simulation sounds good. It looks good, but we'll see how it sounds. A lot of promise there. So I'm really excited about that. I saw Ryan's subwoofer video. It looks great. That Formica looked killer on there. I thought that was a really good choice. Very low key. And I've got a same 60 hertz pesky room mode. So get that
It's a
DSP
very
in.
common thing.
Yeah, it's such a pain.
Yeah.
I'll be honest, I heard it when he first turned it on. It sounded incredible. and I'm like 2 sets away.
Single 18-inch Ultimax. No, I've had the Ultimax 1 18-inch, and it sounds great. So
Yeah.
sealed. And that's what's coming up on my channel. What about you, Nick?
I already talked about mine. Remember, I said I didn't want to end
projector.
it, but I'll
No.
tell you. I just put the projector up. Yeah, I'm glad one of you listens to me.
I'm kidding.
I will say this: when I get off this, I'm going back in the workshop and I'm finishing up this really cool build. It's a little different than what I've done on the channel, but I think it's going to be awesome. I think a lot of people will like it. It's a pinball machine, a virtual pinball machine, and it's going to be really cool. It's epoxy poured. It's going to have some LED lights behind it. It's going to look really neat. I think you guys will like it. And the craziest thing is, I should have it. Oh, well, I can't find it, but it's, oh, here it is. Powered by this computer. This $500 mini computer can do the whole thing. It's crazy. I'm in awe at what this thing can actually do. It's just crazy.
Like a laptop without a screen.
It basically is. Yeah. Cheap. It's cheap. It's amazing. Oh, and you know what? I will say this, by the way, guys, if anyone needs, this is a minis forum. Anyone needs a PC to measure speakers, dude, you can get these for as cheap as $200. As long as you have a TV or something, has HDMI out. You can hook it right up to a TV and have all the measurement software is cheap. And this comes with, are free, and this comes with Windows 11 Pro on it. So for 200, that one's 500, but you can get them as cheap as 200. It would do everything you need for measuring speakers. So
Save you from bringing your nice laptop like me out into a dusty shop every day.
yeah, when I get set up with like a more permanent setup, I'm gonna buy a cheap one of those to have set up. Like, there's no reason.
That's a good idea.
I can do that and even buy a cheap 32-inch television for cheaper than it would be for a cheap laptop.
Yep.
But all right, guys,